We're at gotomath.com working some calculus. Let's go down to concavity. And, ooh, man, looks like we're doing that one again. Lovely. 7-2. 7-2. Round to 2 decimal places if needed. Alright, good. Anyway, it says find the inflection points. So as you can see here, we've got them actually listed on the graph. You can always click this graph and get a new graph. How about that graph? Hope you didn't write that other one down. So this is where we're at. Let's write this down. Let's do it. Name of the function is f. We got 2x squared minus 4 squared, oh, raised to the 2/3 power. Okay. Alright, we got that. Everybody got that written down. Let's, what are we doing? I guess we're going to the whiteboard now. And I'll work that. Let's blue this one up a little bit. We have f of x is equal to 2 times x squared minus 4 raised to the 2/3 power. Alright, and first thing we want to do is take the derivative. So we bring the 2/3 out front, we end up with 4/3, and I'm just going to write all that in the denominator. X squared minus 4, subtract 1, you get negative 1/3. Take the derivative of the outside, chain it out, you get 2x. Okay. Now I'm going to go ahead and rewrite this. This is going to end up being 8/3 over, or 8/3 x, I should say, over x squared minus 4. We want to write this with positive exponents. That means we'll have to take it down into the denominator, and because we're going to be taking the derivative again, and that's what we'll want to do, take the derivative again. So we end up with f double prime of x. So this time we use the quotient rule. So the derivative of the numerator is 8/3 times the denominator, easy enough, minus the numerator times the derivative of the denominator. Did I say that right? The numerator times derivative of the denominator. Okay. And so we end up with x squared minus 4 raised to the negative, let's see, 2/3. Right. And then derivative of the inside, chain that out, so we have 2x. And that's going to be all over. So if I can draw a straight line, or attempt to draw one, x squared minus 4. And because we're squaring this, we're going to end up writing 2/3 here. Okay. Okay, I don't know why, but it seems like this problem was the same, but oh, I think we started with, no, we started with 2/3. 2/3 out front, subtract negative, I don't know. Oh, I remember now. Okay, never mind. Well, what we'll want to do here is simplify this thing down. Okay, and that means we need to factor the numerator. We have an 8/3, we have an 8/3, we have an x squared minus 4, we have an x squared minus 4. But we always pull the one out with the smallest exponent, and that's going to be this guy right here. Okay, so we're going to pull the 8/3 out, and we're going to pull out the x squared minus 4 raised to the negative 2/3. I'm going to start a bracket here. And so we pulled out, let's see, so we're going to be left with x squared minus 4 minus, now we pulled out this 8/3, we're going to be left with a 2/3 x squared, right? We pulled all of that out. Okay, that's what we're left with. Alright, and then this is all over x squared minus 4. I'm trying to write neat. Raised to the 2/3 power. Okay, so we can go now through this and simplify this down some more. So we have f double prime of x is equal to, and I'm just leaving this 8/3 up here in the numerator. So we end up with 1/3 x squared minus 4 over x squared minus 4. Now, if you take this negative 2/3 down into the denominator, we can add their exponents, so that becomes 4/3. Okay? Now what you want to do is look at this and go, oh, hey, what makes the numerator 0 and what makes the denominator 0? And then we plug that on, put that on a number line. Okay? So let's just go ahead. I'm going to change paper here. So let's just write this down. We want to write that. Okay, I got that written down. I'm gonna, yeah. So let me rewrite this. So we have f double prime of x is equal to, and then I just remembered something, 8/3. We'll need to know what the original function was, won't we? Here in a minute. Okay, we got that, and then it's all over a crooked line. Looks like x squared minus 4 raised to the 4/3. So we set this equal to 0. Alright, so what makes the numerator 0? So in other words, we want to set that part equal to 0. You know what? We'll just do that right here. And solve for x. So it looks like we end up with, what do we end up with here? 4 times 3, and then the square root of that plus or minus x. So that ends up being plus or minus, look at here, I think it's a whole lot easier doing it this way, isn't it? 2 square roots of 3 there. Okay? 2 square roots of 3. And then the denominator, that's easy. That's setting the denominator equal to 0. That's going to be plus or minus 2. Since I wrote x over here, I'll do the same thing. So this right here is what we're really after. Okay? That's going to be what we're really after. And now what we want to do is a number line and plugging our numbers onto the number line. Now let's see, we got -2, +2, and this is going to be 2 times, so we know this is going to be out here somewhere. So we have -2 times the square root of 3, and then +2 times square root of 3. But what exactly is that? 2 times, so we know how to check our test points. 3.46. So this is like 3.46, whatever, negative. And then, so we're doing this just to know where we're at here. So if I pick -4 as a test point, we can pick -3 as a test point. We'll always pick 0 if we can as a test point, and 3 as a test point, and 4 as a test point here. Okay, so now what we're going to do is take these guys and plug them into the derivative, and we can't really see the derivative anymore. Second derivative, I should say. When I say derivative, I mean second derivative. I guess we can look at this up here. So if we take negative 4, we get 16 in the bottom, so that's positive. And then, of course, if we take negative 4, we get 16. 1/3 of 16, is that greater than 4? 1/3 of 16. And of course, that's 5.32. So that's going to be positive. Positive. So we end up with concave up, right, from negative infinity to negative 2 square roots of 3. And then we plug negative 3 in, we get 9. So that's going to be positive. And then we plug negative 3 in up here. That's going to be 9 times 9 9 times 1/3 is 3. So that's going to be 3 minus 4. That's going to be a negative number, right? So that's negative. So that's going to be concave down. We plug 0 in. You get negative in the numerator. Plug 0 in. We're going to get positive because we got this raised to the 4th power here. So any kind of negative number down here is going to be positive. We're going to get negative in the numerator, so we get negative. So that's going to be concave down from negative 2 to 2. Then we plug 3 in, right? That'd be the same thing as negative 3, right? So we get concave down. And then, of course, plugging 4 in is the same as negative 4 because we've got these squares right here. It doesn't matter. And so this becomes positive, and this becomes concave up. Now we look where the concavity changes. Well, it's going to change here, right? It's going to be changing here. You got a change in concavity, and then we got a change in concavity here, as you can see. Plus, both these numbers are in the domain of the original function, and that's important because if these were vertical asymptotes here, you couldn't get an inflection point at a vertical asymptote. So that's really important. So what you'll do now is take this and the original function, which was I'm trying to remember. Okay, the original function was f of x is equal to 2 times x squared minus 4. Of course, we're writing it in the exponential form here. 2/3, I believe, that was the original function. So you'll take this negative 2 times square roots of 3 and just plug it in. Now it says round to 2 decimal places. So our inflection points are going to occur at negative 2 square roots of 3, but it's asking for the decimal point representation. So remember that. And so I'll just write it like this. Okay, that's going to be one inflection point, and then the other inflection point will be with the positive 2 times the square roots of 3. Okay, so I think it said round to 2 decimal places. And what is that anyway? 3.46. So this is going to be negative 3.46. And then you go ahead and plug that in, find out what that is. Right, now you'll want to plug in the 2 times square root of 3. Don't plug in the 3.46 into the function, okay? You'll want to plug this actually in right here. And I'm just going to write this here. Okay, and then round to 2 decimal places. So we got 2 inflection points, then you'll want to do the positive one also. Alright, so let's actually move over back to the page and hope like hell that that's what we end up with. And this is actually interesting here. We only get 1 decimal place, but it must be when you plug that in you get 8. But anyway, so negative 3.46 and then 8 and 3.468. Okay, so practice that and we'll see what happens. Alright, okay, get 8 there. All right, and I shall see you back here at gotomath.com.